In this video I wanted to show you how to turn a graph of a secant or a cosecant function into an equation. So before we get into how to do that, I'd like to just kind of review what does a basic secant or basic cosecant graph look like. So here is the basic secant graph, graphed in degree mode, and I've highlighted what one period is. It begins down at the bottom of a U and goes up, and there's an asymptote. There's the top of the upside down U, an asymptote, and then it comes back down again, and that cycle repeats every 360 degrees. So if I am going to try to think about this particular function in terms of secants, then I would need to look for any particular points that I can see, nice grid, nice x-coordinates that are at the bottom of U's. For instance, here's one I might be able to find, or here's a nice one that seems to start a secant curve, and so I might emphasize that by just kind of highlighting one particular period of a secant curve. And if I choose to do that, then I might write my equation using this template, where A is the amplitude and B is the frequency, and C is how far left or right I've shifted a secant curve, and D is the amplitude. Now, if I do choose to write this function using a secant formula, then I would maybe have a phase shift of -2. -2 because I went in the positive direction too, and you always have to flip that sign. So I can also define this by using a cosecant function, and for a cosecant function, that particular graph looks a little different. A cosecant function starts with an asymptote along the y-axis, and then has the the normal U has an asymptote at 180, and then has the upside down part of the U, and then another asymptote, and so forth, and that continues over and over again every 360 degrees. So if I was going to try to define this function using a cosecant curve, I'd have to find a nice spot where I see an asymptote right on a nice grid line. This is, if I have to write a function, I prefer cosecants, because I think in terms of where those asymptotes are, and here's a nice place where an asymptote is at -5, right before a U, and here looks like another one at -1, and so forth, if I were to highlight just one particular one. So here is one complete cosecant cycle. So if I wanted to write an equation with a cosecant, my phase shift would be probably not -5 but +5, because this particular one started in the negative direction 5 units, so I'd put a +5 in here. I think I have to undo it. That helps me remember to flip the sign. So the vertical shift, regardless of which function you use, the vertical shift will be this midline, and so that looks to be about 5, and so I'll write that in. And the amplitude is how much higher up from 5 I go, and how much lower I go from 5. That's not super clear on this particular grid, but I think that is 2. Let me put in a line at y equals 5 minus 2 and see if that lines up with the tops. Yep, and if I do a line at y equals 5 plus 2, then that lines up with the bottoms of those u's. So 2 must be our amplitude. And I'll get rid of those lines a second. And the next thing to consider, the only thing we still have left, is the frequency. And this particular one, it's kind of tough to see the frequency. Either way, I can never see the frequency. I have to find the period. But this one's a little bit difficult to find the period, because it goes, this kind of goes from 5 and it ends kind of midway through between 4 and 3. It's like more than 1, but not quite 2, not quite 1.5. So to figure out what the period is for this so that we can convert that into the frequency, I'll give you a hint to, instead of just looking at one cycle, if we go 1 cycle and then 2 cycles and then 3 cycles, I'm right back onto a grid line. That means that I did 4, or within the amount of, I did 3 cycles in the period of 4 units here. And so that means my period is 4 cycles, that's me, 4 units, and that was 3 cycles. And so what that means is that that is 4/3 of a unit for 1 cycle. That would be my period, 4/3. Now, that unfortunately is not what gets put into the formula, 4/3. What I need to do is I need to figure out the frequency. Frequency is always the normal period, which in degree mode would be 360, or in radian mode, which is what GeoGebra thinks in terms, so I've got to write my formula in radian mode. That would be 2 pi, and then down here is where I'll have to put my fraction, 4/3. And to calculate 2 pi times 4, or divided by 4/3 is not very easy. That's easier to think about if we rewrite it as multiplying by the reciprocal. So if I multiply that by 3/4, that gives me 6 pi off the top of 4, or that reduces to, is that 3/2? Yeah. So 3 pi, oops, over 2. That would be the frequency of each of these graphs. And so I can take that, I think I can copy and paste it. Let's see. Yep. So here are 2 functions that should produce the same graph that we have here. And so to test that, let me turn this off. And I'll leave those ones on there so that we can know if it's in the right spot and so forth. But I need to type this in. In GeoGebra, you can actually type in secant or cosecant function, but on a calculator, you wouldn't be able to type in a secant. You can't find the secant button somewhere. So I'm going to pretend I don't have a GeoGebra, but I have to type this in like I would on a calculator. So secant is the reciprocal of the cosine function, and so if I'm going to type in this top equation, 2 secant of, I have to type in 2 divided by the cosine of. And so then my frequency is 3 pi over 2, and then my phase shift is x minus 2. And plus 5, and if this is right, it should be in just the right spot that the other one was, and it does. Lines up perfectly with those 2 cycles that we had before. So similarly, the cosecant function, if I wanted to graph it using that, I'd have to do the reciprocal of cosecant sine. So I'd type 2 divided by the sine of 3 pi. I have to use a times symbol. 3 pi divided by 2, and then in parentheses x plus 5. And again, the plus 5 at the end, which is the vertical shift, and voila, that's right where the graph is as well. So there's another example of how to graph cosecants and secants and make that all work. Thanks for watching.